What's up? What's up? What's up? This is Lifted Veil, and this is one I'm a freestyle, man. I'm calling this "Where is the E1b1a in ancient Africa?" And people may think that this is an obvious question, but I think I can demonstrate that it's not. A lot of things are taken for granted in terms of Africa and Africa's DNA, especially pertaining to West African ancestry. So-called African Americans. So I kind of came up with this at the last minute. I've been thinking about this and how I would lay it out. So but with this one, unlike others, I didn't pre-plan this. I don't have a pre-strategized format for this one, and I'm gonna see how it go, man. It might, make the final publication. It might not. We'll see how it goes. But I already know a little bit about this. I actually know a lot about it. I've actually been studying it for quite some time, and so I decided to revisit this on ChatGPT, and I'm gonna try to keep this under 2 hours. Shouldn't even really be 2 hours. Should be like a 1 hour thing, but definitely no more than 2 hours. So I've started a ChatGPT. What do you call it? A thread asking about the oldest African haplogroup found in fossil remains. And so I'm just gonna take y'all there, and I think this might come out to be pretty interesting. Where is the E1b1a in ancient Africa? Let's find out. So here I asked ChatGPT, what was the oldest specimen found with the haplogroup assigned in Africa? It says, based on current published ancient DNA evidence, the oldest specimen from Africa with the confidently assigned uniparental haplogroup mtDNA and Y-DNA is from the site of the Tuffarat cave. And here are the oldest well-supported examples. And so you got the Tuffarat cave in Morocco. That Y-DNA is E1b1a, E1b1b. The mtDNA associated with these males is U6 and M1. This is very interesting because I'm pretty sure that M1 is a direct continuation from the ancient Europe's, Y-DNA C population that was present in the upper Paleolithic to the lower Paleolithic into the Neolithic as well. And like I said before in earlier presentations, I demonstrated that population laid the foundation for the Middle East, what we know today as the Little Middle East, what was then called, or in ancient times, the Levant. They laid the genetic foundation for that as well. You see, so now here we're seeing that the Tuffarat is showing E1b1b, and I believe in that genomic study, it's picking it up as Eurasian and sub-Saharan, and I think the percentage was, if I'm not mistaken, I think that percentage was, I think it was like a 30-70, with it being, you know what, I'm just going to ask again. I'll get back to that. I'm going to ask ChatGPT what was that percentage again, just so I can make sure I had it right. But it was part Eurasian with affinities to the Natufians, and then it was part sub-Saharan, with those affinities being closer to what you would call modern West Africans. Okay, so continuing on, the next oldest is the Shamlaka Cameroonians, the Y-DNA A00 and A0. The mtDNA found with them is L0A and L1C. Then you have the Malta Cave in Ethiopia, 4,500 years ago. That's associated with mtDNA L3 and 2A. Now, why am I on the hunt for, the E1b1a in Africa? I think that actually should be pretty obvious because, they say that the E1b1a is only West African and um, it was never in North Africa, in the Nile or anything like that. It was always in West Africa. So I'm thinking, like, if it was always in West Africa, then we should see a presence of it in fossil evidence, as well as the upstream subclades. Because, mind you, the E1b1b is found in the Nile Valley. So, continuing on, it says, why not older? Africa has much older Homo sapiens fossils, including a Jebel Arhoud, Homo Kabich, and the Hurtu. Guess that's how you pronounce them. However, DNA has not been recovered for these remains. Africa's warm climates greatly accelerate DNA degradation, so they cannot currently be assigned Y-DNA or mtDNA haplogroups. An important distinction, if you are asking specifically about the oldest African specimen with any haplogroup assignment, is the Tuffarot, which was 15,000 years ago, currently the oldest widely accepted answer. If instead you are asking about the oldest specimen carrying a very basal haplogroup such as A00, that's a different question. The ancient individual from Shamlaka are the oldest ancient Africans associated with extremely basal Y chromosome lineages related to A00 and A0, although they are younger than the Taffarot individuals. So let me move forward. Let me skip ahead. I'll go on to ask, so no fossil recovered carrying E1b1a ever recovered in Africa prior to colonial times? And it kind of surprised me here because before I wasn't able to really find any specimens with the E1b1a. It says no, that would be incorrect. Pre-colonial Africa remains carrying E1b1a have been recovered by previous answer blurred oldest African haplogroup assignment overall with the oldest E1b1a specimen. The clearest securely sequenced examples include the Zero Botswana, an early Iron Age male dated to roughly 1400 years BP, approximately 6th to 7th century CE, carried the E1b1a, 1a, 1c, 1a, downstream EM2 lineage. Kome, Botswana, an early Iron Age male dated to about 1100 years BP, roughly the 9th through 10th century CE, carried the E1b1a, M2, with assignment including EZ1123. The Deloraine Farm in Kenya, an Iron Age male, carried the E1b1a, 1a, 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 which is EM58, also within the E1b1a M2 branch. These individuals lived centuries before formal European colonial rule in those regions. The Botswana assignments come from Wang and colleagues' genome-wide study of ancient sub-Saharan Africans. Important limitation: what has not been securely recovered. As far as the published ancient DNA record currently shows, is a very ancient Pleistocene or early Holocene African male directly assigned to the E1b1a, E2, for example, someone 10,000 and 20,000 years old. That absence is primarily an ancient DNA preservation and sampling problem. At least that's what they're calling it. Not evidence that the E1b1a did not exist. The lineage's age is inferred from modern Y chromosome phylogenies to be far older than the Iron Age specimens, but the oldest directly sampled E1b1a individual presently appears to be only around 1,400 years old. Also, the Topharats, approximately 15,000 years old males were E1b1b, which would be M78, not the E1b1a M2. So the accurate statement is the E1b1a has been directly identified in multiple pre-colonial African skeletons, but no presently published E1b1a ancient genome approaches the lineage's inferred prehistoric age. See, this is where the suspicion began before. Because I'm gonna ask it on the screen and show you guys how old the E1b1a is theoretically. But before that, I want to go to this next question that I asked you. The ones that were recovered seem much further downstream from the basal form. It says exactly. The ancient individuals recovered so far do not represent any early or basal stage of E1b1a. They belong to relatively deep downstream branches of E2. The phylogenetic sequence is approximately E to E1b1b to E1b1a to E2, numerous later subclades. The Iron Age individuals are already positioned several mutations below M2, such as EZ1123 and the E1b1a. Other branches associated with this later Eastern and Southern African expansion. That means these specimens document populations which E1b1a had already undergone substantial diversification and geographic expansion. They do not show us the original E1b1a founder, an early E1b1a chromosome lacking later downstream mutations, the earliest M2 diversification, or the population in which E1b1a first arose. Modern Y chromosome phylogenies contain men classified as M2 or relatively basal E1b1a branches, especially in Western and West Central Africa, but those are living samples, not ancient skeletons. Modern studies also show considerable internal E1b1a diversity in proposed Western Central African region associated with the early Niger-Congo and later Bantu-speaking expansions. So the larger chronological gap. Formation of the E1b1a, direct ancient evidence, none. Basal E1b1a or basal M2, none securely recovered. Early diversification in West Central Africa, very poorly sampled. Downstream EM2 during Iron Age expansions, yes. Colonial and modern E1b1a diversity is abundant. So, if we're just going strictly by the scientific, genomic, and archaeological evidence available right now, the only significant presence of the E1b1a that's been documented and recovered is in the colonial modern era. Let's move on. This is significant because the recovered individuals cannot establish where the E1b1a originated merely from their burial locations. A person carrying a highly derived E1b1a branch in Botswana or Kenya around 1,500 years ago records the arrival or expansion of that particular descendant branch, not the birthplace of E1b1a itself. The apparent pattern is therefore heavily shaped by sampling. Ancient DNA preservation is especially poor in the humid tropical regions of West and Central Africa, where the most basal E1b1a diversity would ideally need to be investigated. The current fossil record effectively begins after much of the lineage's early history had already occurred. So, where is the E1b1a in Africa? I'm just asking. Inquiring minds want to know. So this is the next question I want to ask. This year. Theoretically, how old is basal E1b1a? Oh man. So the most basal form of E1b1a is supposed to be phylogenetically 30 to 40,000 years old. The EM2 is supposed to be anywhere between 20 and 30,000 years old. So we're missing at minimum um, around 18 to 19,000 to about 38,000 years of phylogenetic support for the E1b1a being in Africa. Just saying. It says what this means. If these estimates are approximately correct, the first man carrying the basal E1b1a would have lived roughly 30 to 40,000 years ago. The earliest EM2 ancestor would have lived somewhat later, perhaps 20 to 30,000 years ago. The Iron Age E1b1a individuals recovered so far are therefore tens of thousands of years younger than the inferred origin of the lineage. Put that in perspective. Estimated origin of the E1b1a is 35,000 years old. Midpoint. That's a midpoint estimate. Oldest ancient E1b1a genome is 1400 years ago. That leaves a gap of roughly 33,000 years with no directly sampled ancient E1b1a males. Why is there such a gap? Of course, they go blame it on lack of preservation. The most likely reason is preservation and sampling. Tropical and subtropical African environments are among the least favorable for ancient DNA preservation. Relatively few late Pleistocene male remains from West and Central Africa have yielded recoverable Y chromosome DNA. As more ancient DNA is recovered from those regions, researchers expect to identify progressively older and more basal branches of E1b1a. I don't think they're gonna find it, man. I don't think they're gonna find it. Because within this indigenous community, we've been saying that the E1b1a's expansion happened during colonial times, during conquest, basically. And we've been saying that the E1b1a came from America and entered Africa from America and then spread. And I'm pretty sure E1b1a was present in the Western Hemisphere in terms of being in Europe. Modern African, so-called African Americans share affinity with Ramses III. That's been documented. I've showed that before, and I think it's at least two individuals that's been associated with that. I got another article as well. um, documenting the. Let me see here. I'm gonna check it off screen real quick. Yeah, I'll just get that on the screen a little bit later. I want to keep this flowing. Matter of fact, we'll just do it right now, man. Let's do it right now. Stop sharing this. We'll put something else up here. I'm gonna have to share this on a window. Okay. This is what I wanted to show, right? So the article is titled Archaeologists Perplexed to Find West African Ancestry in Early Medieval England. Okay. And I had Gemini, I opened up my Gemini to kind of answer some questions about this specimen that's not mentioned in this article. Because this is like a secondary article based on genomic studies, so it didn't have the full data. I'm gonna read it. It's not long. It's titled Archaeologists Perplexed to Find West African Ancestry in Early Mid. Hold on. Let me make sure it's on the screen. Yeah, it's on the screen. Okay. Archaeologists perplexed to find West African ancestry in early medieval England. It says DNA recovered from skeletons buried in the 7th century cemetery on the south coast of England has revealed that buried individuals had West African ancestry, raising further questions about early medieval migrations to Europe. Archaeologists documented significant migration during this period into England from continental northern Europe, with the historical accounts describe the settlements of Angles, Saxons, and Jutes. However, the extent of movement from further afield has remained unclear. To further understand early medieval migration in Europe, researchers performed DNA analysis on individuals buried at two 7th century cemeteries on England's south coast, in Updown in Kent, and Worth, Matravers in Dorset. It goes on to say, the findings published in two studies in journal Antiquity show clear signs of non-European ancestry in two buried individuals with an affinity to present day groups living in sub-Saharan West Africa. Let me read that better than that. The findings published in two studies in journal Antiquity show clear signs of non-European ancestry in two buried individuals with an affinity to present-day groups in living sub-Saharan West Africa. While most of the individuals buried at the cemeteries had either Northern European or Western British and Irish ancestry, one person at each cemetery had a recent ancestor from West Africa, scientists said. Kent has always been a conduit for influence from the adjacent continent, and this was particularly marked in the 6th century. What might be termed Kent Frankish phase, said Duncan Sayer, an author of one of the studies from the University of Lancashire. Updown is also located near the royal centra of Fingalham, Finkelsham, indicating that these connections were part of a wider royal network, Dr. Sayer added. In contrast, Dorset was on the fringes of continental influence, researchers said. The archaeological evidence suggests a marked and notable cultural divide between Dorset and the areas to the west, and the Anglo-Saxon influenced areas to the east, said Sheridan, whatever his name is, J. Edwards, one of the authors of the other study from the University of Huddersfield. The individuals show clear signs of non-European ancestry and an affinity with present-day Yoruba, Mandi, Mandinka, and Isan groups from sub-Saharan West Africa, the study noted. Further DNA analysis revealed that they were of mixed descent, with each having one paternal grandparent from West Africa. The Updown grave was found to contain several goods, including a pot likely imported from Frankish Gaul and spoon hinting at the individual's Christian faith or connections with the Byzantine Empire. The cemetery was part of Kent's royal network, and these grave goods and genetic indicators point to the region's continental connections, the study noted. The other individuals at the Worth Matraver's grave site was buried alongside a male with British ancestry and an anchor made of local limestone. The fact that the individuals were buried along with typical members of the communities indicates that they were valued locally, archaeologists noted. Of course they were. They surprised that they were valued, man. That's funny. But anyway. What is fascinating about these two individuals is that the international connection is found in both the East and West of Britain, said Dr. Sayer. Updown is right in the center of the early Anglo-Saxon cultural zone, and Worth Matravers, by contrast, is just outside the periphery in the sub-Roman West, he explained. The findings, according to the researchers, raise further questions about long-distance movements and demographic interaction in Britain during the early Middle Ages. Our joint results emphasize the cosmopolitan nature of England in the early medieval period, pointing to a diverse population with far-flung connections who were nonetheless fully integrated into the fabric of daily life, Dr. Edwards concludes. And so, like the first default is going to be these were Moors. But let me show you something about that. Go back up to the top. Because the Moorish Empire extended to West Africa as well. So people may still try to default to that. Okay, they mentioned the Byzantine Empire, which was located in the eastern Mediterranean. It says the capital was modern-day Istanbul, Turkey, which sits right on the Bosphorus Strait connecting the Black Sea to the Mediterranean. Core regions: modern-day Greece, Turkey, the Balkans, and parts of the Levant, which would include Syria, Lebanon, Jordan, Israel, Palestine, and Egypt. So again, we've constantly told people that the so-called West African signal was indeed outside of Africa before colonization of Africa. And it was a part of Europe, it was a part of the Levant, etc. And you can see that this is being confirmed here by Gemini. We've said this time and time again that Negroic people were part of the modern Roman and Greek Empire. Matter of fact, um, Dr. Clyde Winters presented some evidence about the indigenous population of what we know today as, modern day Greece and Rome were established by Kushites. You know what I mean? And I ain't gonna go that deep into it, but as you can see here, that area is associated with these West African individuals. And so let's keep going. I wanted to show something here. I asked, did the genomic study yield any haplogroups? Because this particular article didn't mention anything about it, but as you can tell by the reading of the article that they were interpreting the primary study. And so I asked, did the primary study include, any haplogroups? It says yes. Studies published in antiquity yielded specific haplogroups for the individuals with West African ancestry. Because both individuals were determined to be of mixed descent, specifically having one paternal grandparent from West Africa, their genetic markers showed a fascinating blend of European and African lineages. Maternal lineage was E1b1a, not surprising at all. The individual from Worth Matravers, which is associated with the Byzantine Empire, was KD010. Similarly carried the pan-European maternal, the sample was called KD010. The maternal line was U5B1. And the Y lineage, once again, is E1b1a1. M78. This lineage is highly consistent with African ancestry and aligns with studies, autosomal findings showing a genomic affinity to present-day sub-Saharan West African groups such as the Yoruba, Mande, Mandinka, and Isan. Additionally, with the broader Worth Matraver cemetery population, the researchers mapped other local family lineages, identifying a first-degree relationship, either siblings or mother-son, between two other individuals who shared the H1b mitochondrial haplogroup. So I asked, would this time period had intersected with Moorish culture? Let me pull this down. Moorish culture in England. It says, based on the timelines of the burials mentioned in the article, which is the 7th century, specifically around 600 CE, no, this time period would not have intersected with Moorish culture in England. Here is how the timeline break down. The 7th century burials, the individuals with West African ancestry found in Kent and Dorset, date back to 600 CE. At this time, England was in its early medieval Anglo-Saxon period. The rise of Moorish culture, the term Moorish typically refers to the Muslim inhabitants of the Maghreb and the Iberian Peninsula. The Umayyad, I think I'm pronouncing that right, conquest of Hispania, modern day Spain and Portugal, did not begin until 711 CE, nearly a century after these individuals were buried in England. Moorish influence in Europe. While Moorish culture heavily influenced Southern Europe from 8th to 15th centuries, it never extended a political or massive cultural footprint into England. Yeah. Interesting. Yeah. Instead, the article notes that the international connections during the 7th century period were driven by alternative networks, such as trade with Frankish Gaul or connections to the Byzantine Empire, rather than the Islamic Golden Age or Moorish networks, which developed later. So here I ask, what haplogroups did the Moors have? I'm gonna kind of like speed through this because I want to get to something else. So the Y DNA is E1b1b predominantly. J1 and some E1b1a. All right. Maternal lines U6 and M1. These are distinct ancient North African maternal haplogroups. U6 is considered a signature marker of the indigenous Berber speaking populations of the Maghreb. And then you have the L's. And I'm pretty sure this is where most of the so-called West African signal was coming from. And keep in mind, man, when these people are talking about West Africa, man, they're talking about a signal. You know what I mean? That signal is mainly found in West Africa now, but it is just a signal. It doesn't mean absolutely that signal originated in West Africa. And so far as I've demonstrated so far, they don't have fossil evidence for the complete picture for E1b1a originating in West Africa at all. But moving on. So I think that West African signal in the Moors are coming from the maternal line, being that, some of their mothers basically carry the L's. But I'm going to ask something here real quick because it's been on my mind. Isn't M1 a gene flow continuance from upper Paleolithic Europe? See if my memory serves me correctly. Okay, it's saying it's a little bit off target, but it's associated with, it's entangled with West Eurasian prehistoric movements. Genetic data and archaeogenetic studies clarify the true origins and trajectory of M1. The macro haplogroup roots are non-African, of course, primarily centered in Asia. Okay, Eurasian backflow, everything like that. But this is what I'm asking directly and get straight to the point. Cause we ain't gonna mess around. Was it not paired with Y DNA C in Paleolithic Europe, regardless of origin? That's all I want to know. it says the normal parent was U5, but I'm pretty sure that in that earlier study that I did with the Austro-Melanesian, ancestry in Europe, there was some pairing with that M. Um, Maternal haplogroup M1 has not been. Let me see where you're saying the mix-up is. The idea for everyone it stems from a slight mix-up of prehistoric lineages. The Y-DNA-C did exist in Upper Paleolithic Europe. Its maternal counterpart was not M1, but rather early branches of macro haplogroup U. Okay. Uh, All right, I'm gonna come back to that, man. I don't want to spend too much time on that because that wasn't my major focus. I'm pretty sure it was up there in Paleolithic Europe. I had to go back and check again, but I'm pretty sure that it was. Matter of fact, we can stop sharing this, and I can go to back to my ChatGPT thread. I can go straight to the thread where I had all that information saved in the first place. And we can nip this question in the bud real quick. No games will be played. We don't want to go. We'll come back to the other. Based on this study was mtDNA M paired with Y-DNA C in Paleolithic Europe. Taking a little minute, but hey, man, wait on. Ha! Yeah, man, I know my memory. My memory is great. I know I remember what I know I remember, man. And that's what the Goyet Q116-1 from Belgium. mtDNA-M. The 2023 study specifically noted that the Goyet Q116-1 and the 4-non cluster included carriers of mtDNA-M, and that M has not been identified in sample European individuals after the last glacial maximum. The same individual is assigned Y-DNA C1A2 in the ancient DNA records. Come on. I'm putting this together, you know what I mean? It's been put together pretty thorough, man. I know I'm not a geneticist and everything like that, man, but I don't think it's too many individuals painting this genomic picture like I have. Yes, This is a continuation from the Upper Paleolithic Europe down in the Levant. Now, here's the caveat, though. Here's a caveat. Um, there was a presence in the Levant that seemed to have been in seemed to have been there before the LGM. So that M could have moved from the ancient Levant up, but nonetheless, it was there. Whether it moved from the Levant up or not, it was present in the Upper Paleolithic age in Europe. Just wanted to establish that, and it could have been a major population band, like a major network of population interactions or whatever during that time period. But nonetheless, it was in Paleolithic Europe, and it was Paleolithic in the Paleolithic Levant. So you got two things going on. You know what I mean? Now, out of Africa theoretically happened about 70,000 years ago. So mtDNA-M being in Europe doesn't really, put pressure on the out of Africa theory. But the C once again does. And the C being in the Levant very early does as well. I'm just putting this together. So now we're going to go back to the discussion about the E1b1a, because this is what this is truly supposed to be about, right? So now my question is going to be, what about fossils carrying fossils in Africa carrying root clades upstream from E1b1a? Okay. The Malta, Ethiopia. All right, all right. Approximately 4,500 years old, Malta male from Ethiopia. Ethiopia was assigned an original high coverage genome study to Y-DNA E1b1, defined by P2, the relevant tree, E1, E1a, and the E1b1a. Okay. Therefore, Malta's published assignment sits at the parent node of both E1b1a and E1b1b. It is not merely a sister branch like a confirmed E1b1b specimen would be. However, the interpretation requires caution. E1b1 may reflect resolution limits, meaning the specimen was demonstrably derived for P2, but lacked sufficient confidently covered downstream markers to decide between E1b1a and E1b1b. It does not necessarily mean that Malta carried an actual surviving E1b1. Hold on 1 second. All right. So where was I at? I was asking about anything upstream. So it says that the E1b1 may reflect resolution limits to prove basal E1b1. Sorry, to prove basal E1b1, researchers would need to show that Malta was positive for E1b1 P2, while confidently ancestral at the defining mutations for both V38 and M2 15. The original publication securely supported Malta as E1b1 P2, but it did not establish him as a truly basal representative of the approximately 40,000-year-old E1b1 founder population. Okay, so it goes on to say other ancient African lineages. We already went over the offer up those. Yeah, we want the equal. Where is it at? Okay. What about further upstream? At present, the African ancient DNA record does not contain a securely demonstrated specimen carrying a genuinely basal form of DE, E1, or E1b. Wow. So E1b1 associated with Malta was published broadly as E1b1, but insufficient downstream resolution may explain the assignment. E1b, no secure basal E1b. No E1, no E, no DE, or YAP. Hey man, it ain't looking good. It's just not looking good. Um, so I'm gonna ask this defining question, man. So basically, the entirety other than the recent E1b1a is missing entirety of DE to E to the is missing in fossil evidence to date. The African skeleton ancient DNA record does not currently preserve contain. But the answer is no, man. They can say what they want. You know, I just wanted to lay the foundation with this. I'll probably build on this, maybe call this part one and keep building on it, man, and maybe look into some more genomic studies in detail, and maybe, reincorporate the African American shared affinity in the Nile, because that's the only presence where African Americans share, have been noted to share direct affinity with anything in Africa, and that just happens to be in the Nile. And remember, in the Black Indigenous community, we have said for a very long time that there is a relationship between the Maya and Kemet, and so it's all making sense because none of our DNA was found in ancient Africa, only in colonial times, in terms of fossil evidence. So I'm gonna cap it right there, man. I think this speaks for itself, man. Can't wait to air this. So once again, this is Lifted Veil. Peace